You may not know exactly what shape this makes, but this does make a geometrical shape, and I need you to know. I need you to be able to recognize this shape. Okay, must recognize. This is 4 minus x squared, okay, but it's got that square root attached to it. This is a semicircle. If you were to set this up as y equals, if you squared both sides and then move the x squared over, you have x squared plus y squared equals 4. That is an entire circle, okay? If you only have the positive form of the square root, then you're only looking at the top part of the circle. If you had the negative form of the square root, you would only be looking at the bottom, okay? But this piece is the top of a semicircle that has a radius of 2, all right? So let's get that done. So radius of 2. Let me create my semicircle here. So when I am asked, when I'm asked to find the integral from -2 to 2, I'm being asked to find the area under that curve, but because it is a geometric shape, I can use geometry to help me find that. So make sure you get the 1/2. The formula for area of a circle is going to be pi r squared, so this is going to be 1/2 pi r squared. The radius is 2, so the area under that curve is going to be 2 pi. Pay attention to your limits of integration. Okay, this one is really, really important. Obviously, this is some sort of piecewise function. I've just got a series of lines that I'm working with. What I need you to know is that anything below the x-axis is considered negative. Below x-axis is negative. That is what we will call negative area. And the more we work with it, the more familiar you'll be. The more we apply it, the easier that will be to understand. But below the x-axis is going to be negative area. So what we're going to do is we're going to use a property, and we're going to break this up into pieces. So we're going to go from -4 to -1, right, of f of x dx. And then from -1 to 2. And then again from 2 to 4. So we're going to break this up into geometric pieces, right? So equals -4 to -1. This is a triangle, simple enough. So I'm going to have negative, because it is below the x-axis. I'm going to say -1/2, and then the base is 2, and then the length there is going to be 3, right? So base times height of that triangle. Plus, now I'm going above the x-axis. So we're going to have 1/2. Base and height are both 3. Got to be careful trying to squeeze all that in there here. Oh, not equals. Sorry, plus. Got one more. From 2 to 4 is also below the x-axis. So -1/2. And then base of 1, height of 2. And now I have to get my values in. So the first bracket is going to give me -3. And then plus 9/2. And then -1. So you end up with -4 plus 9/2. If you want to go ahead and get a common denominator, that's fine. Depends on how comfortable you are with that. But -4 is -8/2. So you end up with 1/2. Again, this is the idea of kind of this net growth. Like this is negative, this is positive, this is negative, right? So the net area, whenever we go all the way through all of this, is going to give me a positive 1/2, because these are going to help eliminate pieces of that. Okay, that's a difficult thing for us to grasp. We've never worked with area as being negative before now, but it is something that you're going to have to be able to be comfortable with, right? And you're going to have to diagnose it quickly and go, oh yeah, that's below the x-axis. I'm going to have to make that negative.